Still can't say that until everyone takes the quiz. If you missed the quiz on Friday, it's on Schoology. Make sure you take that. Pretty easy. Final list. Yeah, it's a good one. I will say that nobody got it. My final list. No one can figure it out. So, sure, you guys were close. You were within. I mean, I think some of you might have had 2 or 3 in a row correct. Yeah. Yeah, just take it at home. Or, yeah, it's just on Schoology. Pretty easy. Just do me a favor, send me an email or let me know once you have it done, then I'll make sure I can put it in the grade book. Deal? Cool. All right, 7-4, page 53. We're back to the category 1 through 5 hurricanes in the Atlantic and Pacific and Indian Oceans. Okay, this is perfect for chi-square test of independence. Remember, independence means that, as far as this goes, that, you know, whichever of those 3 oceans is doesn't dictate whether it's the higher category or not. It's like categories would happen in any of them. It says, so we wish to wonder if the intensity of hurricanes is independent of the oceans where it occurs. That is, does the likelihood of the intense hurricane depend upon the ocean where it took place? It isn't enough to calculate individual probabilities because there's not only a sample of hurricanes. This chart does not represent all of the hurricanes could ever or will ever occur there. Therefore, we need to see if there is statistical significance, whether strong evidence exists. Oh my gosh, is a mouthful. To conclude with the intensity of the hurricanes is related in some way to the ocean. All right. So it says the default position is that our 2 variables, oceans and hurricanes intensities, are independent, so they're unrelated. So our null hypothesis, ocean and hurricanes intensity are independent. Our alternative is ocean and hurricane intensity is dependent. Okay. So the 2 possible research decision outlines below. Reject the null hypothesis. We find strong evidence that the ocean and hurricane intensity are independent. Our intensity are dependent. And then fail to reject. We fail to find strong evidence that the ocean and hurricane intensity are dependent. Okay. The chi-square test cannot find strong evidence for anything more than dependence. We won't have strong evidence for any particular relationship between the table. For example, a chi-square test cannot be used to find strong evidence that a Category 5 hurricane are more likely in the Pacific Ocean. This is a test for the entire contingency table of data. Either the variables are dependent or not. Hurricane intensity is measured with 5 levels, categories 1 through 5, and ocean is measured 3 levels, Atlantic, Pacific, and Indian. There are 15 cells in the table. All right. So, 15 cells. All right. So each cell requires an observed count, chi-squared value. The table provides observed count. The expected value for each cell provides the number of hurricanes that we expect to see there. Okay, so row total times column total divided by the total total. So let's go back a page. All right. All right. So the equation for that, basically, you have the row total times the column total over the total, total. All right. So row total would be Atlantic. So your row totals would be 53, 39, or 18. Your column totals would be 46, 28, 18, 11, 7. Whereas your absolute total of all the hurricanes is 110. Okay, so what does that find us? This is our expected value. This is our expected value. All right. That's our expected value equation. All right. I can't see my whole thing. Why did you guys tell me I wasn't centered and then I walk away? All right. So, for example, a cell Atlantic category 1 has an observed total of 20 and expected value. Okay, has an observed Atlantic category 1. Atlantic category 1. So if you look at Atlantic category 1, there would be 20 that would be there. Okay? The expected value would be 46 times 53 divided by 1/10, so it comes out to roughly 22.2. In other words, the ocean intensities are independent. We'd expect 22.2 category 1 hurricanes. We actually counted a bit less, which provides us some evidence that the two variables are dependent. So then we go back to our chi-squared test. So this is how we're looking for expected value. Expected value is then used in the chi-squared, where we have the observed minus the expected quantity squared divided by the expected. So being they said, hey, looking on the page, if you had Atlantic category 1, this provided 20 Atlantic category 1 hurricanes. Okay, being that I went across on Atlantic, so if I went as a row total on Atlantic, there was 46. A column total for category 1 would have been 53, and there's a total of 110. So when you plug all those in, this comes to 46 times 53 divided by 110, which comes out to 22.2. So this is your expected value. This is your observed value. So then chi-squared works pretty nicely with that. Just plugging those in. I'm going to get 20 minus 22.2, quantity squared divided by 22.2. And you run through the math, and it comes out to 0.218. Okay, so that is your chi-squared value for that situation. For example, the cell Atlantic category 1 is observed total of 20, expressed value of expected value of 22.2. Yo, good to see you, brother. This computes to what we have. Again, the chi-squared value is a measure of the difference between the actual hurricane count and the count we'd expect that the two variables are independent. The higher the chi-squared value, the more evidence we have that the two variables are actually dependent upon each other. In the next section, we'll pursue through the rest of the chi-squared test. Okay, so the big thing on this, and I'm just going to flip to where the homework is. So it's on page 133. So let's go through and do 1 through 4 and then see what you do. Uh-oh, someone's getting Starbucks gift card. Giddy up. Got this, dude. Thank you.
Yep.
Who is it? Uh-oh. Someone's in big trouble. I got it. Kennard is here. All right. There you are. All right. So I need to write that down. What should I write down? I gotta get myself a piece of paper and a pen. All right, I'm going to write these two equations down so I don't have to keep flipping back and forth and go, what is it? All right. So this is off the homework. So let's take a look at these. What page is that on? 133? How much?
74, right?
Yeah. 133?
Yep.
So page 133, let's do the first one together, or the first four together. It says calculate the observed and expected chi-squared value for category 3 Pacific Oceans. All right, so I get too many things that are going on. All right, so Atlantic, Pacific, Indian, total. Category 1, 2, 3, 4, 5. So 20, 16, and 10. And 46. And then 16, 8, 4, 28. And 10, 6, 2. 18. And then 5, 5, 1. 11. And then 2, 4, 1. 7. And so then we have kind of this total down here. And we have this total down here. 53, 39, 18, and 110. All right. So we want to calculate the chi-squared value of category 3 Pacific hurricanes. Okay, so category 3 Pacific is this. So we have an observed of 6. Good so far? So if we want to find our expected value of this, it's going to be the row total, so 39, times the column total, which is 18, divided by the entire total of 110. So using a calculator, 39 times 18 divided by 110. So this is going to come out expected of 6.4. So then our chi-squared value. So again, this is the row total, column total, total. And then if I do want to find my chi-squared value, it's going to be observed minus expected, quantity squared over expected. So observed is going to be 6, expected is 6.4, divided by 6.4. So this particular one would have a chi-squared value of something. 6 minus 6.4. Okay, we haven't done that. Square that. Divided by 6.4. So this would give me 0.025. So that's number 1's chi-squared value. Number 2, calculate the observed, expected, and chi-squared values of category 5 Atlantic. Cat 5 Atlantic. Okay, so category 5 Atlantic, there's 2. So we observe 2. All right, and then we can say we want find the expected value. It's going to be the row total. So that's 53 times the column total, which is 7, divided by the 110. So 3.4.
Why is there 2?
Huh?
Because there's 2 Atlantic category 5s right there.
Yeah. Yeah, it's the intersection of the 2. And then our chi-squared in this case is going to be observed minus expected divided by expected. So 2 minus 3.4 squared divided by 3.4. So that comes out to roughly 0.58. Okay. And just keep going through there. So I'm going to squeeze number 3 up here, top corner. Calculate the observed, expected, and chi-squared for category 2 in the Indian. So cat 2, Indian. So category 2 in the Indian, there's 4 of them. So our observed is 4. And then we're going to go for the expected, we're going to go 18. 18 in the Indian times 28 divided by the 110. So 18 times 28 divided by 110. So that's going to come out to 4.5 is our expected. And then we're going to make that work. So we're going to go observed minus expected. So we're going to go 4 minus 4.5 quantity squared divided by 4.5. Find chi-squared. So this chi-squared comes out to, bless you, 0.06. And then explain the meaning of the expected value you found in problem number 3. So the expected value we found in number 3 is we were expecting to find 4.5 hurricanes to take place, whereas we just observed 4 of them. Cool. All right, so that's on page 133, 134. So finish up page 133 and 134. And call it good. And if you do need to make that quiz up, you can do it. There's probably time to do it now. Cool?